Hello, and welcome to the latest episode of Data Unchained. I am Molly Presley, your host. So let me tell you just a little bit about what this podcast is about for those of you who may not have joined us yet. The paradigm for data access has really changed. In today's decentralized world, getting data to remote workers, to distributed applications, across different clouds and cloud regions can really be a challenge. And figuring out what content is hidden with that data is even more difficult. Data Unchained digs into the challenges and solutions to make data an asset as a globally accessible resource. Today's guest, Vishwas Prabhu, is a data scientist at Twist Bioscience. Vishwas, thank you so much for joining us today.
Yep, thanks for having me, Molly. Yeah.
You bet. So tell us a little bit about the company that you work for, Twist Bioscience, as well as kind of what was your background that brought you to Twist?
Yeah. So Twist Bioscience, as we know it, like it's a biotech company that focuses on building a lot of synthetic biology products. So one of the main products is genes. That's the strong suit of Twist. So the department that I work in, that's biopharma, leverages this strong suit and then helps build our customers. And reformatting these antibodies and then testing it out. So regarding my background, so I'm a data scientist at Twist Bioscience. I work in the biopharma division of Twist. So that's primarily focused on antibody discovery. So generally my work involves developing these data pipelines from analysis to even predictions using machine learning and a lot of tools, building a lot of tools around this. So a bit of my background in education, like I did my bachelor's in chemical engineering and then my master's was in data science. So And in terms of some personal interests, I love exploring new places, going out and cycling and various other sports. So yeah.
Excellent. And your background in chemistry or chemical engineering is intersecting with biotech and the idea of a data scientist role. Is that common? Do most data scientists in your space have more of a scientific background, or do they generally come from the IT space?
If you look at it, there's at some level people do have some kind of degree in either biotech or chemical engineering to begin with, but then you also need to have some background in CS. I've observed, like in most cases people do have it, sometimes by chance and sometimes by it's because of that degree that you'll get into this field. Sometimes it's very common then, more common than you see.
Yeah. So what was your journey like? How did you choose both your educational as well as your career path?
Yeah. My journey has not been that straightforward, to be really honest. So
Mine hasn't either. I understand.
But thing is, like I've always been fascinated by science, technology, and even the math behind all the things. So I always used to wonder, like, how is this made? What goes behind it? So that's my beginning of why I chose chemical engineering, because when I grew up in an industrial town in India, so a lot of chemical plants and a lot of industries around chemical based, refinery based, and all those stuff. So that's how I got into chemical engineering. So right after my bachelor's, I joined Reliance Industries. So that was which operates one of the largest refineries in the world. So I was working around petrochemicals and all these plants initially, and then my journey began there. I moved into data science position there in the research and development, where I was working in renewable energy space. So there is, like, my background in chemical engineering was starting to go towards computational side. as I joined Reliance in the research and development group, where I was building some models based on kinetics and trying to leverage the data. And eventually, I moved to a data scientist position at a pharmaceutical company called ACG World, which again has second largest, which is one of the largest companies, tableting manufacturer in the world. So that's where I worked on some of the IoT platforms and data coming from this IoT sensors and analysis of those data sets. So after this point, I realized I need to upgrade my skills and really step up. And I decided to do my masters. So I came to United States for my masters, and I during the course of the masters, I joined Twist Bioscience. As a data science intern, and then after my masters decided to pursue this job full time. And yeah, that's how I ended up in biotech field. So the journey has not really been like a straightforward path, I would say. It's been like a lot of fields that I've explored, and that's how I ended up here as a data scientist at Twist Bioscience. So
And that's a great destination. I mean, you think about the interest in data science right now in pretty much any industry, any field, any geography. It's just data science is such an important part of any type of business right now. If you were thinking about folks listening to this show, and a lot of the people who listen to Data Unchained are focused on different parts of the data workflow and data generation components of their business. How would you explain or suggest people get started if they wanted to be a data scientist, whether it's in life sciences or else? How would you recommend they get started?
yeah, to get started, you really don't need to like learn a lot about machine learning to begin with. You just need to try to find use cases in your current work, and then try to apply those use cases and see if those interest you, and then try to move from there and start building your portfolio of data science projects if the field really interests you, and then also pursue some online courses to begin with to build up your skills as you move along the journey. And if you really feel that this is not enough, then I would say go do a higher degree in data science, either master's or even a bachelor's degree. This can be done even online or on campus. So that's a path I would suggest. So, but yeah, if different people have different paths. So I chose the path which involves master's degree, but it might not be for everyone. You might not need that degree to actually get into the field. You can directly get into the field by applying data science to the job that you currently have and identifying use cases. Yeah.
Okay, great. And when you think about at Twist Bioscience and your workflow, can you tell us a little bit about the tools you're using and kind of the workflow that your data pipeline is set up with?
Yeah. My workflow primarily involves using open source tools like Python and open source ML libraries such as sklearn, PyTorch, and various visualization libraries such as Matplotlib, Seaborn, Plotly, and all these libraries, Pandas. Uh, all these open source tools to handle data. So these tools, you these are the things that you would use in any field of data science. And yeah, these are the building blocks for the data science professional, I would say. And for some of the heavy high throughput data workflows, I use PySpark. So this is the distributed compute for scaling some of the workflows across various nodes, or you can say various servers. So this really helps leverage the power of distributed computing. So this is another skill I would say that is uh, that is needed and is part of data scientists' workflow in general. So yeah, and also some of the tools involve natural language processing, being able to parse text data, textual or string data. So these things these things are day to day. I use in my day to day work. I would say.
Okay. And what kind of problems at Twist Bioscience are you and your peers in the data team looking to solve?
Yep. So if you look at the problems would be the primary goal of antibody discovery is to get to that perfect clinical candidate, right? So and I've seen in the past podcasts that you had hosted. So there are various people working at clinical stage. That's on the patient side. You're testing it on either patient side or it's being tested in labs after. Yeah, but the workflow that I'm involved in is how do you reach that stage? So uh, so to begin with, you for an antibody discovery space, to begin with, if you look at the antibody itself, it has 100 residues. Uh, in like it has a heavy chain and a light chain component
Okay.
in it, and each of the chains have 100 possible um, residues. Those are amino acids, and you know that there are 20 amino acids at each position, right? So if you
Mm-hmm.
do the math, the space that we are looking at for antibodies is 10 power 80. So that's, to give a context, that's more than the number of atoms in the universe. So you start
Massive.
with that and you need to get to one clinical candidate. So the way you do that, those are the kind of problems we are trying to solve, how to get to that clinical candidate for our clients, and how we leverage the power of data and leverage the power of compute to get to that perfect clinical candidate. And some of the questions involve like how you from this space of 10 power 80, how you get to a reduced space where the sequences are like possible candidates, and then you can perform experiments based on these smaller set compared to a larger 10 power 80. So how do you intelligently reduce the sample space at each point? So that's the question that we are trying to solve, and through data and all this compute and machine learning. So yeah, that's the overview of what we are trying to solve.
And as you think about the data sets, I mean, these are massively complicated data sets trying to distill it to something simple. Are they all data sets that you own as a company, or you gain data sets from industry collaboration? Kind of where is that all coming from?
Yeah, some of the data set, like we know it, is after the pandemic. The like you can see, go back to the literature and see that after the pandemic, the open source boom started, and that's where various protein data banks and antibody databases started updating. So now you have a lot of data collected for proteins and even antibodies, open source data. For example, if you look at OAS database, which is Observed Antibody Space Dataset, that has billions of records of antibodies, which can be leveraged. So there are open source models that are built on top of it. Like if you look at protein space, there are open source model like ESM from Meta. So these language models enable a lot of workflows. These kind of open source language models, even there are language models on Hugging Face if you look at it. So these open source models and open source technologies are now being leveraged to kind of build technology on top of open source, as well as like there are proprietary data sets where you create data sets from the experiments that you perform. So that's one area, that's the open source. And the other area is when you have experimental data from NGS sequencing, that's millions of rows. So how do you make sense out of it? You cannot manually pick sequences from millions of sequences, right? Like how do you intelligently pick sequences? So that's the second kind of data set. That's kind of closed source, I would say, from experimental evidence or experimental methods. You generate these data sets, and you would yeah you would need to pick candidates out of this. So that's the kind of scale that you're looking at. Billions of data set, billions of rows for the open source, and millions, in the order of millions uh, for the closed source NGS sequencing data set kind of problems.
When you think about the tools you've put together, and like you say, in some ways they're a standard tool set for a data scientist, no matter which industry you're coming from. But when you think about the tools you're building for the consumers of your data, the researchers, the scientists, how does that work? How do you translate mathematics and Python and things like that to something usable by a scientist?
Yes, the way you do that is you would want to generally simplify. You wouldn't want a scientist to run a code, right? They want them to focus on their work that's translating science into business. So for a data scientist, for a data scientist working in a bioinformatics team, you would be really focusing on the back end of building the infrastructure. And finally, this would translate to a scientist using that tool. Either he would enter in the parameters he wants and gets the output the desired output that he wants from the analysis. So the analysis pipeline is what a data scientist would be building in any company, especially in a biotech where you want scientists to make use of the data. So a data scientist really is able to build those custom pipelines in the backend and take care of all the distributed computing and all the machine learning, and all the data analysis part of it is wrapped in a workflow and it's in the backend. That's how a data scientist in a bioinformatics space would work, and a scientist or the end user would just be using the input parameters either through a UI or a workflow, and just getting the output of the analysis. Yeah.
Got it. Got it. And so I know you design those to help your end users and the scientists internally, but you mentioned that potentially some of these tools will be licensed externally as well. Is that a part of growing your business or sharing data, or why would your company go down that route?
Yes. Something like if you've seen Twist offerings, we have Twist antibody optimization as well, Tau software. So this is one of the tools that we have on the website, and we'll be coming up with more such tools in the future as well. The reason why we have this is like we want to have all the kind of services for our customers. The main services that Twist offers is in vitro, that's in the lab, discovery in the lab, and now with the acquisition of Abberis, we have in vivo, that's the experiments in animals or cells, if you say, and then the third pillar, that's in silico. This is the compute platform, and this is basically discovery in the computer in silico. So this is also this is the reason why we want to go into this space where we have specialization and end-to-end workflows built for our customers, and it would be a one-stop shop solution for the customers coming in, and they wouldn't have to leave the platform. So that's the idea.
Okay, great. So let's just to help the audience understand a little bit better what these tools look like. Can you share just a little bit more on that side?
Yeah. So these tools, as we mentioned earlier, are here to help scientists make a better informed decision that's backed by data. So you can look at it like an example of a X-ray, how an X-ray helps a doctor make a better diagnostic based on the additional information from the X-ray. So if, for instance, if you look at an example from a if for example a scientist wants to study a 3D structure of an antibody, or a protein or a certain protein property he wants to estimate, so having a 3D structure of the antibody, he can really accurately generate those structures and then be able to calculate these certain properties like surface charge or surface hydrophobicity and all these things. So these tools really enable the scientists to make better informed decision that's backed by data. So yeah, that's the analogy I would give.
Excellent.
Yeah.
Yeah. And that's something I think all of us can
Yes,
somewhat
and
easily relate to.
yes, and to add this, developing these tools that are capable of having high throughput analysis really accelerates the way we take decisions. So, and this can be leveraged to the distributed computing uh, that we have. So,
Makes
yeah.
sense. So before we wrap up, I do want to talk this the listeners to this show are interested in data pipelines and infrastructure as well as the use cases for data. Can you tell us just a little bit, to whatever depth you're comfortable, about how do you get your data to your tools? How do you keep it secure? Don't share anything confidential, of course, but just a little bit about where your data lives and moves around would be very interesting.
Yes, so the data that we generate gets generated in instruments. So these the data that from the instruments are then stored in a secure cloud environment. It can be like Azure, GCP, AWS. So our workflows would then start at this point. So we would pull this data from the data lake where the instruments had dumped the data. So these workflows would go there, pick the data, and we would perform our analysis. And this is generally done in a distributed way. So on a remote cluster again. So we are not actually leaving the confines of the cloud, I would say. So, for example, I can give you a workflow how it looks like. So, if you have a AWS infrastructure in the backend, the data would go to S3, and then from S3 it can be picked up by a workflow that's running in SageMaker, and the analysis would be performed, and then the output would then be going to a front end or internal or external website and displayed there. So the tools that we use in the compute environment are all the data science tools that I mentioned earlier. So this is how a typical workflow would look like. And of course, like you can have, in terms of these workflows, you can have scripts running as well instead of the notebook environment I mentioned. So these scripts again are developed based on some IDEs such as VS Code, PyCharm, and all such IDEs. So in terms of the notebook itself, it can be something like a Jupyter notebook that's running on a cluster, or a SageMaker that's again running on a EC2 instance in the backend, or a Databricks notebook, which is leveraging the distributed nature of distributed computing that's running on multiple nodes and running PySpark in the backend. So like this is how the tools align and how a typical workflow would look like. So yeah.
Excellent. And as we look at kind of where things are going and what we might want to leave folks with, I'd love to have you comment a little bit on where do you see AI and ML in your field? You can't pick up anything without hearing about right now. So it would be interesting to see what your perspective, and then just maybe a little bit more about where to learn about Twist if folks are interested in more about your science or your tools or anything along those lines.
Yes. So you mentioned AI and ML in the beginning. So in today's age, I don't think any field is immune to these terms. And these, as we have seen in the generation of ChatGPT and large language models, this field is really booming. And I would say the workflows like in 2 years would look completely different from how they look now. So the space is evolving very rapidly. A lot of research, a lot of open source tools, a lot of open source models based on machine learning and AI are coming into the field of biotech. That's especially in the field of protein engineering and antibody engineering. So these tools are increasingly using AI. The the actual term behind AI would be, I would say, language models. That's synonymous with AI in today's scenario. When you talk about AI, it's a language model that's the main part of that AI. So these language models or large language models are trained on like these large databases I mentioned earlier, which have billions of records in them. So they try to understand the grammar pick up the grammar from the protein or antibody space. So that's like how humans learn English or any other language, for example. So you wouldn't need to specify that to a child. When a child is learning a language, you don't tell the child that this is verb, this is noun. They pick that up on their own. So similarly, how AI or language models or a neural network learns is that they would pick up these nuances from the language by itself. So that's a bit on AI and ML. And to answer the second question, that's yeah. To add to the let me add a couple of things more to the first question. So we have seen the field being revolutionized ever since the AlphaFold models got released. So that is solving the protein folding problems, which had been a mystery before AlphaFold came in. So that's one of the first tools, open source tools, that was accurately able to describe the protein folding. And ever since that, we have had explosion in this field, explosion in open source resources available, open source models available, and lot of this was based on structure. And now we have a lot of language models again coming in to the field of protein engineering. Yeah, and yeah, as you can see, you know where it's going. Like there's a lot of research again going on in this space. So it's a bit hard to keep up at some point with the advances in the literature and open source tools that are getting built, honestly. So yeah,
it's hard
that's
to keep up even with
yeah.
the language and the new things that are evolving, much less how to
Yes,
use
even
them
the
and be an
jargons.
expert.
Yeah,
Exactly.
even the
I find
jargons are. If you look at the jargons, there are like few shots, zero shots, and something like fine tuning, transfer learning. Like these are some of the jargons that you see in the field of AI, and very easy to confuse each of these jargons with what they mean. Yeah, and it's evolving at a much rapid space. Yes, and I'll answer the second part of the question now. So, which was how do you learn more about Twist Bioscience, or what we do, or what the workflows are? I would say the best space to go learn about this is on our YouTube channel. There are like a lot of videos from our CTO Aaron Sato. These videos are again recordings of either some of the conferences or external audiences that we had done in the past. So that's and also some of the videos from our CEO Emily Liprost. So you can watch these videos and get some insights. I would say that's the best resource to go, apart from the Twist website. Yeah.
So Vishwas, thank you so much for taking your time today. I would say sometimes the data scientist role for the non-IT specialist is a bit of a dark art. It's difficult to understand how it folds in, and there's so much complexity to the tools and the math and the data. I've been asked regularly to have a data scientist come onto this show, and so here you are. And thank you so much for joining us. We really appreciate you taking time out of your day to do this.
Yes, thank you, Molly, for having me again. Like this is a great platform, and I've been getting a lot of messages on LinkedIn on like the exact questions you asked, how to get into the field, and what are the kind of tools you use, and like these are some of the commonly asked questions, and I feel like it's a lot useful for someone new to the field to understand where to start and what are the right tools to use. So yeah, it's a great podcast, I feel like, and it's a good decision, I think.
Excellent.
Yeah.
Well, thank you for taking the time and sharing your expertise. Have a great weekend.
You too. Bye.
Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.